Okay, so now we've got the solver nicely set up. What we're going to do is actually model this distribution problem we have. Now to do this, we're going to start first, and this is for future models, in fact, that we're doing this, but also for this one. We're going to start off by defining a couple of custom cell styles. So the goal here is to have these styles ready at hand to make to make your spreadsheet nice and intelligible. So I have a certain cell style for constraints, for data, for decisions, and for the objective, and also for headers, just to make certain elements of my spreadsheet stick out. So now that I've defined these custom cell styles, what I'm going to do is I'm going to go about setting up the model. So to do this, I'm going to follow exactly the same way as I did in class. I'm going to start off by defining the data that we have, then I'm going to move on to the decision variables, then the constraints, and then the objective. So the first thing I'm going to start off with is actually the data. So in the data here, I have a couple of things that are given to me in the problem. So the first one is transportation costs. So how much it costs to transport everything from the plants, the warehouses, and then from the warehouses to the clients, to the customers. So those are one type of data that's given to me in the problem. We also have data on the capacity of each plant, so I'm going to input that as well. Second and thirdly, I'm going to input the demand at every single client base. So let me start by doing that. And then I'm going to make sure that everything looks very nice by formatting everything and using the color coding that I described previously. Okay, so I'm done with the data at this point in time. I'm now going to move on to the decision variables. So the decision variables, as we established in class, the decision variables, there are 10 of them total, and they correspond to how much we're shipping from both the plants to the warehouses and from the warehouses to the clients. So I'm going to draw these tables up. So I'm done with my decision variables at this point in time. I have 10 of them. I now move on to my constraints. So maybe the constraints part is the hardest here because there are a couple of constraints to bear in mind. So the first thing that we need to think about is the amount that's produced at every plant can't exceed the capacity of that plant. So that's the first constraint I'm going to encode. The second constraint I'm going to encode is that anything that goes into the warehouse comes out of it. So that we have an in equals out system. Basically, the warehouse doesn't stock any product. So anything that goes in comes out. So that's the second set of constraints I'm going to implement. And then the third ones are the linked supply and demand. So we want the demand to be fully satisfied for every single customer base. So this means that we need the supply for that arrives at every single client base. We need that supply to be greater or equal to the demand. So those are the three sets of constraints that I'm going to encode right now. So note that to find the quantity that's produced at P1, the quantity that's produced at P1 is the quantity that is shipped from P1 to both W1 and W2. So I write this here as the sum of the quantity shipped from P1 to W1 and the quantity shipped from P1 to W2. I do similarly for P2. Okay, so I have the first constraint set up. Now I'm going to do the out is equal to in for every single warehouse. And this is done by equating what goes in to the warehouse. So what goes into the warehouse here is whatever comes from both P1 and P2. So the quantity that comes from P1 and P2 and that goes into W is what comes in. And what goes out is whatever is shipped to C1, C2, C3. So we have these equations here. I repeat the same thing for W2. And then I start on my third set of constraints. So that's linked to supply and demand. So the supply at every single customer point has to be greater or equal to the demand. So what is the supply here? Well, it's whatever comes in to C1. So it's the sum of both what comes from W1 and what comes from W2. And then we want this to be greater or equal to the demand. So the demand here, we have it, it's a fixed number, it's part of our data. So I just replace it here, and I do the same thing for everything else. Now I move on to the last part of my problem, of my setting up my model, which is writing out the objective. Now, so the objective here is just the cost. So the objective here is just the cost, which means that basically I'm just looking at the amount that it costs to ship from P1 to, from all the plants to the warehouses. And then I'm going to look at the cost in a second part. I'm going to look at the cost that it takes to ship from the warehouses to the clients. And once I have both those costs, I'm going to sum them to get the total cost. So how do I do, for example, from the plants to the warehouses? That's my first part of the objectives. Well, that's simply the sum of the product. So I use the following Excel formula sum product of this array with this set of decision variables. So it's simply, you agree with me, the transportation cost times the amount that I'm shipping. And then I do the same thing for from the warehouses to the customers, and then I sum the two to get the total cost. Okay, so at this point I've completely set up my model. So what I'm going to do simply is I'm going to use the solver at this point in time. So I go into data and I click on solver. Now the solver appears looking something like this. So I first start by setting the objective. So here I click on the only green cell I have on my whole spreadsheet. So note that this is where the color coding comes in useful at this point in time, so I don't even have to look. I just click on what's green. Now I'm minimizing the cost, so I will have to click min here. Then they're asking for the variable cell, so the decision variable. So the same thing here. I simply pick what's yellow in my spreadsheet to be my decision variables. So I have these 10 variables here. And then I have to add the constraints. So here in the constraints, I'm going to add them one by one. So I'm going to write out, so in this particular case, I'm looking at something less than or equal to something else. So I write on my left-hand side here is a set of constraints on the left, and I have less than or equal here and the capacity on the right. So I add these to my model, and then I keep going with the other two sets of constraints. So now I've got the model nicely set up. The only thing that I'm left to do, so I will keep this box checked. So this box really reads make unconstrained variables non-negative. We're looking at quantity we're shipping here. So obviously the amount of the variables which we have here are going to be non-negative. So I'm going to constrain them to be non-negative, these variables. I picked select a solving method, so you may have something else. Here we're going to go with simplex LP. This solves linear problems, which is the case of our model here. And then I simply click on solve. So I just click OK here to keep the solver solution. OK. And then I can read off the solution. So here we have the total cost, which is $740,000, which is what we were expecting to find from the previous slide. And here I can read off the decision variable. So this here I read off how much quantity I should be shipping. So I should be shipping 140,000 units from P1 to W1, for example, and 60,000 units from P2 to W2. So from this, I can read every single variable I wanted to fix. I can read it and I can find the minimum cost that's achieved.